colors. Now this table, it was already filled out, but they could question you on the next paper about either the state or the colors. For melting point, we know that it would increase as you go down the group. Remember physical properties such as melting and boiling point, as you go down the group, it increases. Anybody want to explain why the melting point increase as you go down the group? Anybody have any?
Cause density increase.
All right. Well, in terms of
As it goes down the group, like it needs stronger attractions to break the bonds.
repeat that one.
As it says, it goes to need a stronger attraction to break the bonds.
I'm not hearing it clear. I hear something about attraction and bonds, but it's something to do with the bonding. So what can you
So I
tell
would say
me?
that as it descends, the group is going to need a stronger intermolecular attraction to break the bonds.
Oh, as they go down the group, the intermolecular force of attraction is stronger. So it would take more energy.
To melt or boil.
So question, can you tell me why, as you go down the group, the intermolecular force of attraction is getting stronger? Before you tell me why it gets stronger, can you tell me the type of intermolecular force that is present?
Van der Waals.
That is correct. And when it comes to van der Waals, the bigger the molecule and the more electrons present, the stronger the attraction will be. Right? So that's just, so as I go down the group, the boiling point, melting point increase. Now, in terms of bond energy, as you go down the group, it actually decreases. And anybody tell me why?
Is it because the electronegativity of the atoms decreases?
Repeat that. You're kind of breaking up.
I would say, is it because the electronegativity of the molecule decreases going down the group?
But also the size of the atom. So because fluorine is smaller, the attraction between the chlorine and the hydrogen is stronger. So that bond, it would be harder to break. Right? So the smaller the molecule, the harder that bond is going to be to break. So iodine is a very large molecule. The attraction that exists, it will not be as strong as fluorine, which is a much smaller one. All right, so bond energy, and the next one now, the final one, is the inert value, and we will look at how this applies. So for fluorine, it was positive 2.87. Let me write that better. Positive 1.36, positive 1.07, and positive 0.54. And remember, these data, you will get your data booklet with these inner values as well.
So are they going to give us the color, or we're going to be the one to give the color? But like the color, are they going to give us the color, or should we know that by heart?
No, you should know the color.
Sir, we're going to get the melting point in Data sheet.
No, but like if they want to, if it's not a general trend that they want you to tell them about the melting point, but you will not need to know the exact value, the melting point, but you must know the trend. So the melting point decreases as you go down the group. All right? But like color, you should remember the color as well as the states. All right? But like the exact value for bond energy, no. All right. All right, so that was the table given for us. And then we have some questions to answer. So when it comes to the melting point, right? All right, so let me answer the question. It says, or let me put it on the board. This was question 2, not question 2, question 6. Six A. They asked us to explain the trend. All right, so explain the trend in volatility of the halogens going down the group. So volatility. So if you're up, so volatility, basically, like if you know you have bottle of alcohol and you leave it open, this scent, it will gone after a short period of time. So basically, easily it forms a vapor and escape.
Sorry, decrease down the group.
That is correct. Give me a second. Just a second. Right. So as you was, someone was saying it would decrease, and that is correct. If you look at state at 20 degrees Celsius, chlorine is a gas. Chlorine is a gas. So these would be very volatile. Now, if you put down a bottle of water, and let's say a bottle of alcohol, the alcohol would evaporate quicker than the water. If that happens, it means that, remember, when you boil water, you are breaking the intermolecular forces. So remember from unit 1, sorry, not unit 1, from Friday's class and module 1, I think I told you that when you boil these compounds, right, or heat them, you are breaking the intermolecular force. You are not breaking the actual covalent bond. So easily, the intermolecular force, by the way, what is the intermolecular force in water?
Hydrogen bonding.
Hydrogen
Right.
bond.
Hydrogen bonds. So basically, easily it is to break your intermolecular force of attraction that determines how volatile the substance is. So if it is easy to, the intermolecular force is very weak, then that substance is going to be volatile. So chlorine and fluorine are gases. Their intermolecular forces are weak. It is easily to break. Not much energy needs to be applied. If it is easy to break, what does that tell us about the intermolecular force in terms of a trend now?
It decreases down the group.
That it is weak.
Weak.
Right,
Weak
it's
force.
weak, right? As I go down the group, it gets even weaker. The question, going down the group, well, going down the group, volatility is going to increase, not decrease. Right, so if I had said it would decrease, no, it will increase. So going down the group, volatility, sorry, let me not mix up myself. Volatility is going to decrease. Sorry, yeah. So it will decrease. Why will it decrease? What is happening as I go down the group?
The number of electrons increases.
As well as something else increase.
Atomic
Van der
radius
Waals forces.
The
One less
atomic
side of
radius.
it.
atomic radius increases.
Right. So
Yeah.
two things happen. All right. So to answer this question, right? We first identify we know that it has to do with the intermolecular force of attraction. So we know that the intermolecular force, just a second. The intermolecular force of attraction is Van der Waals. All right. So since it is Van der Waals, we need to know what affects Van der Waals forces. And that would include the number of electrons and the size of the atom. So once you identify this, right, let us state the trend. So it says explain. So let us state it first. All right. So as you go down the group, so first we state our trend, right? Now we explain. So we know that the reason why it is going to decrease is because the strength of the intermolecular force does what?
Weak.
What happen- increase as you go down. So this is because the strength you can put intermolecular force in bracket if you want. Oh, by the way, it's for 2 marks. So as you go down the group, volatility of the halogens decrease. This is because the strength of the Van der Waals forces increases. And if you want to add, I guess you could mention now this, the size of the atoms and the number of electrons increases, which is why the strength would increase. Right? So we state the trend and we explain it. So the strength of the Van der Waals force increase. All right. Let me just add that. As the size of the atoms and number of electrons increase. This same question here, right, where it says explain the trend in volatility, it could easily have said explain the trend in melting point and boiling point. But if tomorrow you say boiling point or melting point, it's the same reason. Because boiling point, melting point, that is dealing with breaking the van der Waals forces. All right. Let me add something here. You can understand a little more. Hold on. So there of the relationship between volatility and boiling point.
Sir,
Yes, go ahead.
so you said that the when we say boiling point or the melting point is the same thing for the explaining as at the validity, the valid whatever.
Right.
Okay.
Yeah, because with volatility, it is looking at how easily you break the intermolecular force. And when you are boiling something, the lower the boiling point, it means the easier the intermolecular force of attraction is to break. Right? So that is why I'm pointing it out that high volatility means a low boiling point. The bond is easy to break. All right, so if tomorrow you should see trend about melting or boiling point, you stick with the reason. All right, so part B. All right, I'll give you about 30 seconds, right? And then I'm going to